Hello and welcome to today's webcast, How to Leverage NetApp Snap Managers for Oracle to Accelerate Backup and Cloning of Oracle Databases, brought to you by Datalink. I'm Chandani McDermott. I'm part of the marketing team here at Datalink and will be your moderator today. Before we begin, I do have a few housekeeping items. This webcast is designed to be interactive between you and the presenter. The webcast console you're looking at can be completely customized. You can resize, move any of the windows that you have open. At the bottom of your audience console are multiple application widgets you can use. If you have any questions during the webcast, you can click on the Q&A widget at the bottom and submit your question. We will address the questions at the end of the webcast. All questions from this webcast will be captured. If you are experiencing any difficulties, please visit the webcast help guide by clicking on the help button below the presentation window. It is the question mark icon and covers many technical issues. Our presenter today is Senior Solution Architect Andrew Nelson. I would now like to turn this presentation over to our presenter. Andy, please take over.
Thank you. Hello, I'm Andrew Nelson. I've been a Senior Solutions Architect for Datalink for close to 10 years, and I've been working with the Snap Manager for Oracle products since it was first released, and actually some of the workflows and scripting that NetApp had come out with before the product actually existed. This webinar is broken up into effectively three pieces. Here's the agenda. We're going to go over the Snap Manager architecture and the components for people that haven't been exposed to it before. I actually have a little bit of an interactive demo that we can actually do on a live system in our labs to show you some of the functionality if you haven't seen it, and to walk you through some of the interface functionality for folks that already do have this tool. And then the third section of the webinar is some common troubleshooting tips and architectural design considerations if you're looking to roll this out or you have it in place already. And this is broken into these three pieces specifically because we may have a mix of customers that may or may not have experience with the product. If you have questions along the way, please submit them in the chat window and we'll try to accommodate as many as we can at the end of the presentation. I also have my email in the slide deck, and you can send me emails afterwards if you have other questions that we don't get a chance to cover. So Snap Manager for Oracle, the overview, I'm not going to necessarily read the slide. All of the NetApp Snap Manager products do something very similar. They all put an application or an application suite into some form of backup mode, and then take snapshots, and then remove the application from some specific supported backup mode. In the case of Oracle, we're using archive log mode and hot backup mode, if you will, depending on how you think about it. The table spaces are being put into backup mode. A snapshot is taken of the data files. The table spaces are taken out of backup mode. An archive log is ejected via a log switch, and then we're taking a snapshot of the control files and the archive logs only. The process is run it was actually jointly developed by NetApp and Oracle back when the product first came to be. It's a supported backup method for most Oracle instances. But again, you heard me mention archive log mode. The process really only works in an online sense when we're in archive log mode. This also, if you notice in some of the notes I have down below, we can actually use this in a DataGuard architecture where we're doing DataGuard replication. There's a few caveats that Oracle, or I should say NetApp, has documented around this. There's specific modes that the second database has to be in, and there are parameters that have to be removed if we're going to do cloning and recovery. And that's not something I'm going to get into in this specific session, but just know that this can play in a DataGuard architecture, and we've done that in the past. From a clustering perspective, we can use RAC and ASM. DirectNFS is also supported. We're going to talk about that near the end of the conversation in terms of design decisions. Some of the protocol and Oracle layout considerations make a big difference around this product. We can also integrate with RMAN. We get that question asked a lot when we do SMO deployments. The product can actually sort of replace RMAN functionally. It has its own repository or catalog like RMAN has, and it can work in a totally standalone sense with its own scheduler. But some organizations want to populate the RMAN recovery catalog with the metadata of the backups so that their reports and reporting infrastructure is populated with all of the detail. So that can be accommodated It really doesn't allow RMAN to trigger too many operations, but it's great for legacy reporting and legacy management portals and things like that if RMAN is integrated. It's also supported on most of the Unix and Windows platforms. We've actually, Datalink specifically has rolled this out onto Oracle on Windows in a few cases, and that's not as common an architecture, but we see that in some embedded systems that are all Windows-based, especially in the VMware landscape. The Unix platforms vary by support. We most commonly see this in a Linux realm, but I personally have implemented this in HPUX and AIX in the past. Those become a little bit trickier as HPUX isn't getting the so-called love that we see in the industry so much. And I think that's most of, and then the other big caveat here that I have here is that generally SMO operations can be performed in single-digit minutes. We can generally do backups in 3 to 5 minutes in most cases. It is not affected by the size of the database. That's a common misconception, and that's one of the big benefits of SnapManager in general, whether it's Oracle or SQL, is the actual physical size of the database doesn't affect how long these backups and recoveries take. But the complexity of the database layout greatly affects it. So I had an implementation years ago that had thousands of table spaces and was a very complex data layout. That actually took almost an hour to take backups because of the way that the table spaces had to be put in and out of backup mode and all of the enumeration that went on inside of the tool. But the size of the database does not impact this. I mean, I've actually taken backups of 4 terabyte databases in under 10 minutes. So just know that it's all about the layout of the database rather than the size of the database that affects that. And we'll get to that topic at the very end. So then this is another slide. This and the pictures that follow are slides that I put together. There's multiple components to SnapManager for Oracle. It's one of the more complicated SnapManagers that NetApp puts out. The only one that's comparable is probably the SharePoint, SnapManager for SharePoint. The reason that there's some complexity to Oracle is because Oracle is a fairly complex database architecture. There's lots of moving parts and pieces. So to go through this slide a little bit, there's an SMO server component, which is a Java-based service that actually runs on each one of the Oracle servers. And I'll show that to you when we jump over into the demo. There's a concept of an SMO client, which is a Java-based CLI command line tool that actually can trigger backups and restores and cloning and make changes. The one disclaimer is that everything in SMO is built on Java, so whether you love it or hate it, that is the truth. The SMO client becomes pretty difficult. The first thing you notice when you run it is sometimes it can take a little bit to load because it's actually loading a JVM just to run a CLI. GUI is actually a Java-based GUI that can be run on the actual Oracle server. It can also be run remotely on Windows, and I've actually run it off my Mac in kind of a semi-supported way. The SMO GUI talks to the SMO server just like the SMO client does as well, and I'll show you a picture of how that works. But the GUI and the client are the two interface options for the admin to be able to configure backups and restores, clones, and recovery. And that's exactly what I'm going to show you in the demo in just a minute. There's also an SMO repository, and this is probably the most misunderstood piece of the architecture. It requires a schema somewhere in Oracle, and it has to be in a database that it's not snapshotting. So the SMO repository is just basically a single schema or a single user account with a handful of tables. It's a really pretty small database schema, and in most environments it's 100 meg at most. In some really large complex environments, you'd get up to being a couple gig. It's very similar in function and form to the RMAN catalog. So it actually stores all the metadata for all the SMO configurations. It stores all the logs, all of the output of the tool, and then it saves all the metadata of what the database looked like at that point in time and where all the snapshots exist. And all of that is stored inside that one schema. The neat part about this architecture is because it's a database that's centrally accessible, I can have people connecting with the SMO client or the SMO GUI from all over the world, and as long as they point at the right repository, they don't have to populate anything on the tool. So the tools itself are stateless for the most part. The repository is what keeps all of the data. So the challenge with that repository, though, is the disclaimer I said before, is it can't snapshot itself. And that's just a dependency issue, is that you wouldn't want to be triggering a recovery on a database that your metadata lives inside. So what we end up doing with most customers is having a couple repositories, and they snapshot each other. the prod repository snapshots the dev repository, or site A snapshots site B's, or so on and so forth. But that's about the only trick to this architecture, is figuring out where that repository needs to live. It's also very easy to pick up and move because it's not very complicated. It's something that with other customers I've exported and imported it into another instance very easily. And it also belongs right next to your RMAN catalog in terms of availability. It does not affect any of your database availability. It just affects the ability of the SMO tool to function. Very similar to if your RMAN catalog is down, you generally can't take backups and restores. So if a customer already has an existing RMAN catalog instance, we tend to stick this schema right next to it because it's in form about the same in terms of availability, function, performance, etc. The other piece of the puzzle, the next one down, is SnapDrive. So SnapDrive is probably the most important component with all of the SnapManager tools in general. SnapDrive does all of the work. It's actually talking to the operating system and the NetApp filers and triggering snapshots, connecting ones, disconnecting ones, and triggering all of the low-level operating system functions. Most of our problems in an SMO environment are due to SnapDrive having some issues in some sense. And I'll talk about that when we get into the troubleshooting tips. SnapDrive is not a specific component to SnapManager for Oracle. SnapDrive exists for all of the SnapManagers as well as most of the operating systems, and it can actually be a standalone tool if you want to do scripting and snapshot recovery management on your own. So you'll see it in other places. The host utilities is the next thing I list down here. Host utilities, instead of tunable parameters, and every operating system delivers them or inherits them slightly different. NetApp packages them in a form that's very specific to the operating system. So for AIX, it's a specific package. For HPUX, it's a specific package. Host utilities is commonly missed in most SnapManager deployments. It isn't called out specifically to install it in any of the guides, and it isn't a dependency that breaks the SMO install. But what it is a collection of tunable parameters for the OS, and in some cases it's a couple command line tools in Unix that actually give us some extra functionality. It's something that NetApp support requires. Datalink makes sure that the host utilities is deployed because it actually can affect some of the stability and performance of the environment. Specifically, I call it out on the slide just to make sure people don't forget it. It's easily forgotten. We find out in a lot of cases in a support call that the one piece of the puzzle that was missed was 2 tunable parameters that this would have set, and that would have kept a specific Oracle instance from failing over during a data on tap upgrade or something like that. So that's why this is spelled out. And then I've also got RMAN listed because it can be a component to the SnapManager for Oracle workflow. So the next 3 slides are rather interesting. These are something that I had to kind of crudely put together years ago. There wasn't a great schematic on how all of these pieces fit together and communicate. And this might be a little bit of an eye chart for those on the WebEx. But I have 3 different pictures of what NFS looks like, what an OS file system looks like, and then what an ASM architecture looks like. You can kind of see, and I'm not necessarily going to go through it in gory detail, but you can see how the SnapManager GUI is talking to the SMO repository the same way that the command line is talking to the SMO repository, and how they communicate with the RMAN catalog and basically dependencies. This is a very useful chart when you're trying to troubleshoot why one component isn't working correctly. It's generally got a dependency on some other component. So for example, you notice that the SnapManager for Oracle agent, or the SMO server itself, is the one that actually does the communications to Oracle. And sometimes it talks through a listener, and sometimes it talks around the listener, depending on how the database was set up. You also see that it doesn't talk to the operating system directly. It's actually using SnapDrive to talk to the Oracle server's operating system and the NFS stack in this specific case. The other point I want you to notice as I flip through the slides is the number of boxes and circles I have here. Those are basically the different subsystems that are actually doing work in the architecture. And as I step through these slides, you're going to see more and more complexity. So if I go from NFS to Fiber Channel, you'll see that in a standard Fiber Channel or iSCSI infrastructure, if you will, we add 3 or 4 other components to the mix on the operating system side. There's more components inside of the server that we have to coordinate operations with. Every one of those extra steps makes things slower, and it also makes things more complex to troubleshoot. And you'll see how that fits into the end conversation at the end of the webinar. So then here's ASM. ASM is very common in our rack clusters, and it's been the norm for most Oracle deployments for the past probably 3 to 5 years. It adds a couple extra layers over the top of the standard fiber channel architectures. It also adds a whole bunch of extra functionality from an Oracle DBA's perspective. The challenge with it is a lot of that extra functionality that we leverage in ASM, we tend to turn off in a NetApp environment. So we tend not to want to do things like automatic rebalancing of LUNs. That actually isn't very efficient in a NetApp. That's almost a conversation for another time, but just know that if you're doing an SMO deployment over ASM, you want to talk to your friendly neighborhood engineer about rebalancing. You want to talk to it about how you're doing abstraction and LUN sizes, because a lot of the functionality that we install or we're hoping to get out of ASM, we tend to disable or not use in a NetApp environment, just simply because the NetApp is already doing it down at an aggregate level or a volume level. The big takeaway here, though, is just the extra complexity and the extra steps, because you'll see when we go to do snapshots and such, the extra steps actually show up as duration in the backup workflows. So what I have in the next slide here is I've got a live rack cluster, and I've specifically got it set up with NFS and ASM and file system-based fiber channel databases in our lab. And the reason I'm showing this twofold is one is to show you some of the operations if you've never seen it before, and also to know that we, Datalink, have live lab systems that can be somewhat checked out to customers. So if you want to test some new architecture or some new database layout, again, talk to your friendly neighborhood engineer. They can actually set up lab time on some of these systems to be able to mock up a database environment and trigger these kind of workflows. We also have the ability to import customer databases within reason. I've actually done that with some customers where we get a USB drive's worth of data ingested in and imported in and lay out your database on our infrastructure. As long as your legal department rubber stamps that, that's something we can accommodate. So I'm going to switch over here to to my desktop here, and please let me know if you can't see what I'm showing here. So hopefully you all can see that I've got a command line on one of my Oracle servers as well as the SnapManager GUI. And I'm running this off of the Linux box itself in X Windows. Because it's Java-based, it looks slightly different if you run it in Windows or if you run it on Mac. The layout is exactly the same. It's just aesthetically slightly different. So I'll go through the GUI here very quickly. So the GUI has these 4 tabs built into it. One of them is a monitoring tab to watch for specific operations, and I don't have anything in flight right now, so this won't show anything. It has a scheduling tab, so I actually have similar to, and forgive me if I insult any of the Oracle professionals, but similar to SQL Agent, I actually can have my own scheduler here for SMO to trigger backups. And you can see here, it gives me a very easy dashboard to look at which one of my backups was successful, and I purposely left a couple of these failed jobs in here. I actually had, there was an outage in the lab when we last run, or actually in this specific case, the database was down when this one was triggered, and they haven't run since the database has come up. So you can actually see failed jobs here, and I can actually go look at the specific properties of the schedule, and I can see some of the details of when it was configured. And I believe from this view, I can jump in and see this is exactly what I wanted. So I can see the last run that happened at this time. And this is what's really cool about this product. We'll get into this with troubleshooting. All of the logs are actually stored in that instance we talked about, that SMO repository. So even if I didn't get an email saying this job failed, or even though I didn't necessarily have the logs in front of me, I can very easily go back in time and see where the problem was. And you can see here that it was complaining, the first error in the logs here is that it can't read the database metadata because the database was down. And so I went and started it up, and then the next jobs have succeeded on that specific database. And you can filter based on errors and warnings. This is pretty useful. And just to kind of get into this, we'll get into this more in troubleshooting. But most of the error messages are fairly human readable. And if they're not, if they're at all cryptic, they tend to be Oracle pass-through errors. So we'll see OERR and some number string that's coming right out of Oracle's troubleshooting. So if it's a very cryptic error that's spitting out an Oracle error code, Well, that's kind of code for the DBA needs to roll up its sleeves and go figure out what Oracle error that means. But the SMO-specific errors tend to be fairly user-friendly, if you will. And simply, it's working top-down to see where the first error in the logs are, and generally that points you in the right direction. But we'll get into that more with troubleshooting. So I can also trigger jobs from this view. So if I want to rerun this backup, it's as easy as right-clicking and saying run. I can also go in and tell it, I can just simply wait for the schedule to kick it off again, but I can go in here and rerun a failed backup pretty easily. And what's cool about this interface is it's giving me very much of a play-by-play as it's doing every step. And so you'll see here that it generates a unique backup label. It'll go and figure out the starting state of all of the databases, and it'll make sure that if we told it to start and stop databases along the way, it'll make sure that they get put in the state that they started when it's done. You notice it might have scrolled by a little fast, but it's doing a control file to trace. It's actually putting the database in and out of backup mode. It's taking snap. It's already finished that part. Now it's actually backing up control files, and then it'll go do cleanup at the very end of the job. It'll go update RMAN or control files, making sure that any sort of RMAN metadata gets cleaned up, and old snapshots and retention that when we've told it to remove old snapshots, it'll go do that at the very end of the job. Let me pull this up so that people can see. So you'll see here it does a dynamic discovery of storage. This is one of my other favorite features in most of the Snap Managers, is these things aren't doing a whole lot that we couldn't script manually, but the one thing that they do very elegantly is they auto-detect where everything is. So if somebody comes along and adds a table space or moves a table space or changes the layout of the database in some fashion, every time a backup runs, it'll go detect that. It'll automatically use SnapDrive to go. It'll query the database first. It'll map those to operating system objects, and it'll use SnapDrive to find those operating system objects, and then that will get mapped into storage structures. And it does that all dynamically. That's good and bad. The bad part of it is if we mess up the layout in some fashion into an unsupported config, or let's say I pick up parts of the database and put in a Hitachi array, for example, the next time SMO runs, it'll throw up its hands with errors saying that it can't figure out where stuff is. But this is one of the neatest features, too, is I don't have to keep track of where my data files are, where my redo logs are, where my ARC logs are. I find that a really useful feature. But that's what it does when it first starts. Then it'll go and you can see here how it is actually creating snapshots of the data files. So it put it in hot backup mode, should be right up at the top. See if I can find it in here. It'll take here it is. It's taking it out of it. Here it's taking it into online backup mode. It's taking snapshots of the data mount points. Then it is taking the database out of backup mode. Then it does a good old-fashioned log switch. So all of these steps under the covers are very standard Oracle calls. So it's doing a log switch, and then it's basically forcing that archive log switch. Then it's actually grabbing the control files and the archive logs right after the log switch. And this is no different for NFS than it is for Fiber Channel, than it is for ASM. The key, as I showed you on an NFS-mounted database first, you notice that's about 49 seconds. Now let's see if my demo holds true. If I do this on one of my other more complex, all these databases are exactly the same size. It's just the layout that's different. So if I run it on a file system-based database, I would expect this to take a little longer because there's a couple extra steps involved. And you'll see a lot of the same steps along the way. And again, all of this output is also stored into that repository. So one of the common requests we get from most database administrators is, can I get these emailed to me? The answer is yes. But then the flip side to this too is all of this sits inside a lovely database. So do you really want a huge inbox full of logs? If so, then we can accommodate. If you want to do report by exception and only get notified when things fail and you want to go look at the logs after the fact, that's totally legit as well. Yeah, so I got lucky. In this case, this is about the same. So this one here took about 43 seconds, so it's slightly faster. So let's try one of my ASM databases. So this is a 2-node ASM database over Fiber Channel, a very typical config for most customers. And I'll talk about the database layout when we get into the architecture here. Unfortunately, my systems aren't heavily loaded, so there isn't a whole lot going on in the environment. But again, the beauty of Snap Manager is that this isn't putting a load really on the system. Besides a couple Java processes triggering some of these operations, there isn't a heavy CPU load. There's no data movement besides the archive log switch. We can run these backups during the middle of the day, and the only impact to the database is coming in and out of hot backup mode. And we're only generally in hot backup mode for a minute or two at most, so that makes this very attractive for doing multiple snapshots a day and being able to snapshot around the clock when we don't have traditional backup windows. And I can probably show you some of that in this other window. So if we run top on the server, you'll see that there's just one Java process at the top doing work. But there's very little data movement. There's very little I/O going on in the system. This doesn't generate a whole lot of overhead. So there's a little bit of an illustration of what I'm talking about. Is an ASM database of the same size, the same layout, adds about another 20 seconds of operation onto this. If I was to add another 10, 15 LUNs, so this database today straddles, I believe, 5 LUNs. If I was to add another 5 or 10 LUNs to this database, we'd also see that 1 minute probably go up to a minute and a half, 2 minutes. We're not talking about doubling or tripling necessarily, but we're talking about adding extra complexity and extra moving parts and pieces. If I had this straddling 2 or 3 different filers, that could go up a little bit higher. But the more complexity you add to the database, the slower these operations. So that's a backup. I'm going to jump over to the backup and cloning tab to show you that I can also trigger backups here. I'm not going to because it's the same thing we just did. But you can see here that I have my current backups in the interface. And from these current backups, I can trigger a restore or I can trigger a clone. I can trigger a verify and a mount. So the mount is useful. The mount simply creates something called a flex clone in the filers and remounts them back to the database and does nothing else. So this is useful even in an ASM context. It'll actually rename the ASM disk group to some unique name and then just stop. And if you're a very savvy Oracle DBA, that's useful because I can take the DBF files and I can take the control files and I can go grab my control file from trace and put the pieces back together manually. I've had a couple customers that were ex-Oracle employees that really, really wanted to do most of this manually, and all they were really looking for was the mount option. I'm going to actually show you a clone because what a clone does is it actually does the mount, and then it actually runs through all of the standard cloning operations that we would do manually in a database cloning exercise. The reason I'm going to show you a clone too is the clone is actually the same exact thing as a restore recover, except it's going to a new mount point rather than the existing one. So for the sake of time, it's easy for me to show you this functionality, just so you get a feel for it. And this is one of the other primary reasons DataLink uses this tool a ton. Even if you're not interested in the backup and recovery functions, being able to do automatic or manual cloning in seconds to minutes is a huge thing for some customers. I mean, I've actually had a couple customers that have double-digit terabyte databases be able to do cloning in 15, 20 minutes, and to do that in a traditional sense can take hours to days. So we have to give it a new SID. So NFS DB1C2. I can give it a label. That's just for my purposes inside here. If we've got multiple DBAs working in an environment, I can put my name on here that this is Andy's. Same with comments. I can pick the host it goes back to. It does not have to go back to the existing host that the snapshot was taken from. If I'm going to another host, I have to make sure that I have the same storage connectivity and similar Oracle versions and so on and so forth. But I can actually clone from host A to host B. This reserved space for clone is interesting. That comes into whether we are thick or thin provisioning this clone. And then this clone specification is the other interesting piece. So if I'm doing this on a reoccurring basis, I can save all of these settings into an XML file and feed it back into the tool for automatic cloning. That's useful. This is good old-fashioned archive log recovery. So SMO's recovery and cloning is all basically media recovery. So I am going to recover the database, and I'm going to play forward all my archive logs that I know about, and I can also feed it other locations if I've managed to move archive logs around. And that's sometimes common practice in larger environments is they tier archive logs into different locations, and if that's the case, or if I've manually copied them somewhere, I can actually add those archive logs to this cloning process, and it'll roll the database as far forward as it can. So this is a neat tool. So this section of the tool allows me to make changes to the layout of the clone. So if I want to add or remove control files, I can in here. If I want to add or remove redo log groups, if I want to change redo log groups, if I want to change the size of them, this is super useful from going from prod to dev to test. Is prod may have a ton of redo log groups with different sizes because of the workload that's on it. And maybe in a dev and test environment, we don't need that much complexity. We can actually change that on the fly. Same thing with parameters. I frequently need to change the SGA in a clone from prod. If my prod instance has a huge footprint and my dev instance is much smaller, I may need to tweak some of these. This is also where if I'm dealing with rack databases or if I'm dealing with DataGuard instances, I'm going to add or remove parameters in here that way. And I can also add other parameters as part of a workflow. I can also trigger a whole bunch of SQL scripts once the database is up. So this is super useful for masking social security numbers and being able to clean out specific columns, remove tables. The short answer here is if you're doing cloning manually and have scripted certain things in SQL, this is exactly where I put it. I can have that triggered automatically. And then I can also change users and groups and Oracle home parameters. So one of the questions we get all the time is, can I go from 11 to 12 in a clone? From an Oracle version perspective, the answer is no. The reason they allow you to change Oracle home is I may have 11.2 installed in a different location on a different server, or in like an SAP context, I'm going to have a different Oracle home for each of the different instances. It's useful to be able to redirect that. But this is not so that you can change versions on the fly, because this isn't doing any sort of import-export. It's just connecting the DBF files and starting them. And I can also have pre-post-test batch scripts. So these are OS-level scripts that can be pre-staged, and I can trigger them at the end of the clone. And all of this stuff, so you can kind of see it. So these steps, if you kind of follow what it's doing, the first few steps are going to be snapdrive calls to create flex clones inside the filer, reconnect them to the server in question with a new mount point and a new name. And then from that point on, it's very standard Oracle cloning. It's going to generate a new SID. It's going to open the database reset logs. You'll see a lot of those steps along the way. So a lot of people think there's lots of smoke and mirrors and black magic in this tool. Really, a lot of it is stuff that we're used to. Anybody that's done any sort of automation with clones, you'll actually see step by step what's going on. And when we get into kind of the troubleshooting steps of cloning, frequently this is where we'll run into weird Oracle error strings. There's been a few bugs around DB-NewID and things like that happen to manifest themselves here. So what this is doing right now is creating a flex clone and then trying to map it back to the host and mount it. And in true demo sense, this is a live system, so we'll see if Murphy shows up and causes me issues here or not. Okay, so it's actually connected the data files. Now it's actually generating the new parameter files. We fed it, starting the database in a no mount mode, like you can see, so that we've actually got a mounted database, and it's going to make adjustments to the control files. If you notice, they're generated new binary control files on the fly. Then it actually rolls the database forward to a specific consistency point. Then it'll shut the database back down after this and do a reset logs, open it with reset logs. So now it's doing another snapshot connect here to get to my archived ARC logs. So this is actually, it did the data files first, and then it'll connect up my ARC log point, whether it's same or different, and it'll allow me to roll forward my database to whatever point in time we had from the backup perspective. And that's, again, where I could feed it extra archive logs if I wanted to. And then once this is done, you'll see that it'll roll the database forward, shut it down, bring it up with reset logs, and go. And I know this is totally riveting for everybody on the webinar. So it's opening the database reset logs. So one of the questions we frequently get asked about this is, do I need to protect my redo logs? SMO does not care about redo logs in any way, shape, or form. This is media recovery. It's assuming that the redo log contents are worthless both in a recovery and in a clone. So if you notice, it didn't use the redo logs for crash consistent recovery. It went right to archive logs and did media recovery. And so in a reset logs context, the first thing it does is wipes the redo logs when the database comes open. That's just part of a normal clone. But redo logs don't get snapshotted, and we'll talk about that at the very end when we talk about architectural design. But this should be like the last couple steps on this guy, and then we're done. And let me show you one of the covers here. You should see that we have a new mount point here, right here. And again, I'm doing this over NFS. Fiber channel and ASM work the same. But I have a new mount point here with the database underneath it. And the operating system can't tell that this is a flex clone in any way. There's my control file, my redo logs, and if I come to NFS DB1, you can see there's my data files. It's a really simple database. And if I care where those things live on the clone, I can go back in that one screen and change the paths and the directory structure and things like that. But the one thing that's kind of interesting about these clones is they're disposable. So I am going to create them, and most of the time I'm going to use them for a few days or a week and remove them and then recreate them from the original snapshots. So then we have to think long and hard about, do we really care about what the data file layout looks like if these are very transient? Because I can clean these up just as quickly as I created them. So if you notice, it's about 3 minutes. And if this database was a lot larger, it would take 3 to 4 minutes. I mean, obviously the reset logs is going to take a little bit longer on a bigger database with larger redo log groups. But it's not, we're not talking 30 to 40 minutes. We're talking 3 to 5 minutes, 10 minutes. This is very dependent upon the number of mount points and the size of the mount points, not from a capacity perspective, but from complexity perspective. And then I can refresh this just as easily by nuking it and recreating it. And I can do all of these operations from the command line as well. I'm not going to go through that in detail, but there's an SMO command line option. You can see job on action here. I type SMO, wait for Java to run. But there's an SMO backup, create as one option. That actually takes snapshots. I can do an SMO clone, create, and that does what we just did in the GUI. I just have to feed it most of those parameters on the command line. It gets to be kind of a chatty command line, but we can totally put this into any sort of batch schedule that the customer is interested in. So there's cloning. I'm not going to go through recovery for the sake of time because recovery is exactly the same thing. So in a recovery sense, all it's doing is disconnecting a table space and either copying the file into place or moving the mount into place. And that's an interesting conversation. If my database exists on just a single mount point and I want to recover just an individual table space, file copies happen under the covers. We actually mount the snapshot under a different directory and copy the DBF files into place and then basically online the table space. Now we're talking about the size of the file matters. If I've got a 1 terabyte table space, that's going to take a little bit to do a file copy on. Whereas if my data files are by themselves and I'm trying to do data file recovery, SMO is smart enough to look at the recovery we're doing and figure out what files are also on that mount point. And if he can disconnect the whole mount point and slide it back in time and reconnect it on the fly, he'll do that. The tool is smart enough to do the most rapid recovery possible, but the database layout dictates most of that. And most of the problems or complaints we get in a recovery scenario are because of the fact that we've got multiple structures in a database commingled. And I'll show you what that means here in just a second. So that's kind of the pseudo demo piece of the webinar. If you want to go through that in much more detail, again, it's the same disclaimer. Talk to your account team, and we can schedule a much deeper dive. We can actually get your hands-on lab time with this gear over a VPN if necessary. I'll leave that kind of as a disclaimer. So let's go back to the slide deck. So now we're going to jump into kind of troubleshooting tips, and then we'll talk about the architecture a bit. So I mentioned this before a few times. Most of our SMO problems that we run into in the field, both in an implementation and in a support environment, have more to do with the infrastructure than the actual innards of the database or load on the system. Almost always the cases, the support cases are around a change that was made architecturally. So another mount point was added, new table spaces were added, control files were moved, authentication to and from the filer has changed, versions have changed. Most of the time it's infrastructure-related problems that trigger these support cases. Very rarely is it the product itself just losing its marbles. It's almost always caused by some change in the operating system, some patch, that kind of thing. Now that I know sounds like a normal IT disclaimer, but we're used to looking for database problems with database backups, and in this specific case, they tend to most of the time be infrastructure related. In other words, I've had customers that have changed a DNS entry, for example, or they don't have the right host entries for the filer, or somebody went and did a password change. The underlying Snapdrive tool uses usernames and password pairs to authenticate, and if you change the passwords, it'll break these backups. And it may not be totally apparent in the logs exactly the fact that some password got changed last week, and that's why my backup stopped working. But the Snapdrive piece is the first bullet I have here. Snapdrive really needs healthy network connectivity to the filer. And it's out-of-band network connectivity. So I could be doing fiber channel runs, and fiber channel may be working just fine, but my IP connectivity might be going through a firewall. I may have some firewall rule that got put in place or pulled, and so Snapdrive can't talk to an interface on the filer to authenticate. That's a really common issue for us. And it's fairly straightforward to troubleshoot. Basically, a good old-fashioned ping to the filer. There's some Snapdrive calls that can be run to test against the filer to make sure that it can authenticate, and so on and so forth. The other issue that we run into all the time is storage changes that have taken place that Snapdrive can't deal with. So Snapdrive is fairly intelligent in most operating systems. It can figure out raw devices from file system devices, from NFS mounts. It knows how to deal with multipathing most of the time. But where it gets really kind of wrapped around the axle is when we start putting third-party file systems in place like OCFS or ACFS or ZFS for that matter. VXFS is another one that in certain operating systems throws it a curveball from Veritas, or Symantec, now Veritas again. Those file systems aren't generally on the support matrix for most of the operating systems, and those get introduced without checking whether that's supported or not, and then Snapdrive can't deal with it. And Snapdrive is pretty good about telling you unsupported file system in its logs, it can't figure out that kind of layout. So beware of those kind of changes that go on. Again, that's a very low-level infrastructure change. Another problem with backups and to some extent some of the cloning operations is sometimes we get full volumes inside the filer, and that's not generally apparent to the database administrator that may be triggering this. It should be apparent to the storage team. Sometimes they're one and the same. But if we have full volumes, we can't take snapshots, and all of these operations in some form leverage NetApp snapshots under the covers. That's a super easy one to fix. We either delete an old snapshot or we grow the volumes. Both of those operations tend to take minutes, not hours. But that's a common one that we run into is this will be chugging along for weeks or months just fine, and then all of a sudden we'll have backups fail, and it's related to the fact that the storage is full. And again, that's not always apparent to the DBAs that might be manning this tool. Generally, that's where the storage team and the DBAs have to work in concert with this tool. Database layout issues are another one. So I've had customers that move control files around, and they may move a control file to a mount point that's not on a NetApp filer. The bigger occurrence is archive logs. So frequently we'll put archive logs in a couple different places per Oracle best practice, and one of those locations might not be on a NetApp. They might be on JBOD. They might be on local disk. And SMO struggles with that. SMO needs to be able to discover the storage and take snapshots. Now, there's a way around it with archive logs, is we can tell it to manually exclude specific archive log copies, but just know that if you make those kind of changes, that might be the first thing that the backups choke on is, hey, we moved our archive logs to a new location. A good example would be some of our customers put archive logs on a data domain or a quantum device and those will actually break these backups if SMO is trying to take a snapshot of them. The other one that's one that comes up pretty often, and it should be obvious, but it isn't always, is a database that's in a non-consistent state. SMO doesn't try to fix it. So I've had customers specifically that have done cloning operations that didn't complete cleanly, or if we're moving clustered databases to a standalone instance, or DataGuard, if we're promoting DataGuard instances to a primary copy and they aren't quite in a consistent state, SMO will throw its hands up. And it'll generally tell you that right away in the discovery phase, that it didn't like what it saw. You'll also see issues with databases that are not that are stuck based on a log switch. So I've run into cases where archive log mount points are full. The database is trying to perform a log switch and it can't write the archive logs. SMO wants a healthy database at the beginning and at the end of the snapshot, and if it can't get it, unfortunately, that's Oracle 101 type stuff, and SMO really isn't your problem at that point, but it may show up in the SMO logs first. So some of the other troubleshooting tips and themes that we run into, I talked about it already. SMO's got some pretty decent logging. There's also very cryptic logging outside the GUI. You can actually generate a zip file of all the logs in the system. I didn't show you this in the GUI, but I can right-click one of the backups and say generate logs. It'll generate a big jar ball that we can submit to support, and they can pull apart all the logs in the system that way. SnapDrive, that's a little bit more cryptic, but it has its own logs in varlog sd-trace star. There'll be a whole bunch of logs in varlog on most systems. They're very cryptic, very chatty, but if you know what you're looking for, sometimes the errors will jump out at you. Frequently, it'll be a cannot authenticate, can't talk, can't discover this file system, so on and so forth. I think I talked about the Oracle errors. ASM and ASM lib are really tricky in this specific case. If you're in a Linux environment with ASM lib, make sure that you have that working and set up correctly. So I have customers that deploy ASM lib, but then they bypass ASM lib by going right to the dev SD devices, or they go to dev Oracle ASM disks rather than the ORCL : devices. All of those kind of little nuances can cause some problems in this tool, and it's not topical to go through it in this webcast, but know that if you've got ASM, you're adding 2 or 3 extra steps to the process, and make sure you talk to your account team and your engineers. Don't always try to set this tool up on your own if you're a customer. This is fairly complicated, and make sure that you get help on the first instance, getting SMO working. The second and third ones are easy, but it's working through all the ASM nuances the first time around that can make a big difference. Same thing with cloning to a second server. We run into this all the time where we're taking backups on server 1, cloning to server 2. That's a trick because the 2 systems better be set up similarly. We better have all the same SnapDrive versions, all the same SMO versions installed. Oracle should be in similar places. We frequently run into issues where the second server isn't fully functional, and it comes out in the cloning process. Because keep in mind, when we're doing cloning, all we're doing in this specific case is hot attaching the DBF files and the mounts and expecting all the Oracle binaries and libraries and everything to be ready to go, so that when we do basically under the covers, we're just doing a SQL Plus startup on the database. We're not doing a whole lot of recovery. And then the last one I have here is just a disclaimer on RAC and DataGuard. Both of them are supported, but both of them have caveats. So if I'm cloning out of a RAC instance to a standalone instance, I need to remove some of the RAC parameters from the database. And the other question we get asked all the time is, can I clone into a RAC infrastructure? The answer is yes, with an asterisk. I can clone into a RAC infrastructure, but only to a single server. To make that database cluster aware, you have to do that with manual steps. And they aren't necessarily manual, they can be automated, but it's not something SMO does. SMO isn't cluster aware on the clone. It's cluster aware on the backup, but it's not cluster aware on the clone. You have to determine how you want RAC to handle that. And DataGuard is really tricky because there's very specific states that the standby database has to be in with DataGuard. So make sure that you either read through the release notes on it or talk to your account team. DataGuard is tricky. It is supported in specific fashions, and it's very useful to have a DataGuard relationship and clone off the second copy. That's a really neat architecture, but it also takes some forethought and planning because there's some extra parameters and complexity. So that's kind of the high-level ones that I run into with troubleshooting. The other piece that I'm going to put in here disclaimer-wise is we frequently get asked, I'm trying to do a restore to a second server. How come it's not working? Well, it's because you really want to clone to the second server. A restore in SMO sense it doesn't put the data on a second server. It's actually putting the data back into its original location. So if we want to quote-unquote restore to a second server, we're really wanting to execute a clone. And then lastly, I've got a few more in here, but I think I just covered a couple of them. Yeah. So the other one that we want to talk about is one of the last two bullets down there. From a recovery perspective, it allows you to do all the standard Oracle recovery options. I can recover just control files. I can recover with the original control files and old data files. I can tell it which archive logs I want to use. Those are all very standard Oracle recovery steps. This just has basically a wrapper around those kind of functions. And I just covered the last one in here. So in terms of design decisions, this is what I was kind of alluding to in some of the other topics. Infrastructure design makes a big difference on how well this tool performs and functions. If I have a ton of complexity in my environment, SMO struggles to keep up with it. It isn't a deal breaker, but the more LUNs I have, the more work it does. So for example, we've got a lot of old EMC shops that create lots of 50 gig LUNs and have tons of 50 gig LUNs under ASM control, and that's a very common thing we run into. Snapdrive hates that because it's got to do so much more work under the covers to figure out what each one of those LUNs is, and to take a snapshot of each one of those LUNs. There's no performance benefit on a NetApp to having hundreds of LUNs versus just a couple. So very rarely do we recommend having lots of level complexity. Less is more almost always. The other disclaimer I have in here is NFS works really well because there's less plumbing. There's less pieces in the operating system we have to work through. I know that tends to be very religious and political, but if you can look at DirectNFS and some of the new stuff Oracle's doing with DirectNFS, those architectures almost always perform more stably. They tend to be much more efficient from a cloning perspective, so on and so forth. I already kind of talked about ASM and some of the complexity it adds. The other one that's the biggest one is the second bullet from the bottom, is we absolutely want to make sure that we separate redo logs, archive logs, control files, and data files into separate mount points. Now that flies in the face sometimes of Oracle best practice, and this is again almost a whole separate conversation unto itself, but the more you do that, the faster your recovery will be and the more efficient your snapshots will be. SMO doesn't need redo logs ever. So why would we snapshot them? And if I put redo logs on the same mount point that my data files exist on, I am going to snapshot them. And I'm going to keep that change and churn no matter what. And that is a really common complaint we get from customers is, how come my snapshots are so big? Well, it's because you put your redo logs with your data files, and they're capturing a ton of change for no good reason. Again, this is a conversation we can have in a sales campaign, or we can have it in terms of a post-sales engagement where we can sit down with you and kind of map out NetApp and DataLink best practices around layout, but that can make a huge difference. And I just talked about the last bullet. So we've got about 10 minutes here, give or take. So if we have specific questions, this would be a good time to pose them. Chandani, did you have anything that was on the chat window?
Yeah, we got 3 questions that came in while you were presenting. The first one is, how would you recover a snap backup from tape once the backup has been deleted by the repository?
So it's Mr. Skoblik. I know you well, Wayne. So the challenge is if we archive these to tape, how do we get them back into a place where we can use them as a snapshot? I think that's what he's asking here. If once the snapshots are removed from the filer, a lot of the usefulness in terms of speed goes away. So if I use NDMP to pick these up and put these onto a tape, or if I use a backup product to scoop them up and put them on tape, then the recovery is very manual. It's very much putting the data files back into place and starting up Oracle manually. It's doing log replay manually. There isn't an automated GUI to take it from tape, put it back to disk, and automate the recovery. It's very much like old school Oracle, where we used to shut down a database and tar it off to a tape. The way that we recovered that would be tar it back into place and start up Oracle. That's very much how the tape recovery works. There isn't great integration that way. If you're looking for a tiered architecture for SMO, that's where we start looking at SnapVault and some of the vaulting products. They have hooks into these tools so that I can actually keep a second disk copy on a cheaper tier of disk, if you will. And because they're still in a snapshot format, I can still use SMO to do some of that recovery. That was broken and clustered on tap, but is slowly coming back in the next 6 months. 7 Mode has had that functionality for a long time. Hopefully that answers Wayne's question to some level. The difference between SMO and Net Backup looks like the next one. So they're both calling the same functions inside of Oracle. So if I'm assuming you're talking about like the Net Backup agent. When you're using Net Backup agent to do backups, you're actually making a lot of the same API calls, if you will, into the Oracle instance. You're putting it in the hot backup mode, and you're generating log switches, and you're doing all those same functions. But the difference is when SMO goes to take a snapshot, Net Backup is doing some sort of file copy. So all we're doing is capturing the state of the data file and then immediately coming out of backup mode. Well, with Net Backup, we have to sit in backup mode for a long time while we're sucking those data files off to disk or tape. And the database is effectively in and out of the same state, but then the backup format is way different. So if we look at how Net Backup stores that, it's actually storing that as streams onto tape or disk media, and you have to recover that through Net Backup. What's interesting about SMO snapshots is if I mount them somewhere, even on a non-Oracle server, I just have data files sitting there. They kind of look like a cold backup, if you will. I can actually look at the data files directly, the control files directly. They're really kind of two different approaches to the same thing. One of the other things that we run into all the time is we have a lot of Net Backup customers as well that are trying to integrate the two, similar to Wayne's comment. If you are doing both Net Backup agent backups and snapshots and SMO, you have to be very careful about what process is doing archive log maintenance. You don't want both of them to be truncating archive logs. You don't want both of them to necessarily be controlling point-in-time replay. And that's a conversation, again, for an engineer with your account teams to figure out which one makes the most sense. Do I let SMO manage and truncate my logs, or do I have Net Backup do it, or do I do it in a third process after both of the snapshots and the backups are complete? That's another big issue between SMO and Net Backup. And that, again, is a more detailed conversation if we want to have it at another time. It looks like the next one, after creating a clone of a backup from one host to another host, with the load on the original one and the original host backup. This is a great question. So when we're creating clones, we are not moving data inside the filer. That's why it's so fast. So when I create a clone off of a database snapshot, I'm effectively pointing all of my reads at that snapshot and writing to new blocks right next to it. So from an I/O load perspective, there's no load on the original server per se, but there's totally a load on the aggregate that's housing the primary copy. So this comes up all the time. If I take a snapshot in prod and present it to my dev server, can my dev server affect my prod server? Well, the answer is yeah, indirectly, yes. Because they're sharing the same spindles and the same aggregate, if I fire up a heavy workload on the dev box, they're not exercising the primary LUN in any way, but they're exercising a copy of the primary LUN, which by nature sits on the same aggregate. So if I don't have enough spindles in that aggregate for both workloads, I could run into problems. Now, that's the answer the other way, though, too, is frequently in a NetApp architecture, we like to have oodles and oodles and oodles of spindles in a big aggregate. And as long as I've got more spindles in that aggregate than I have load, I'm okay. But that's also where SnapMirror and SnapVault can come in, is in some of the architectures I can replicate to another filer or another aggregate, and I can clone off the second copy. The disclaimer there is in clustered on tap, that's broken right now, and 7 Mode, that works great. And I've done that with some customers where we clone off a second copy, and that's how you actually get the I/O separation. The key point, though, is that the primary server isn't affected at all. It's just the aggregate that its copy lives on does. So indirectly, you can get some crosstalk, if you will. Yeah, there's a question around, can I download the slides? Absolutely. I think, Chandani, you're going to distribute the slides, right?
Yep, I'll send an email out to those that are registered after this webcast. Otherwise, that's the last question. It's in the top of the hour, so we'll close it out. Thank you for attending today's Tech Tuesday. Our next session is scheduled for Tuesday, April 21st. We're skipping March. Please watch for the invite. An on-demand version of this webcast will be available within 2 to 3 days. You'll receive an email from On24 to connect it to the on-demand recording. If you have any topic ideas, suggestions for future Tech Tuesday, please send them to techtuesday@datalink.com. Thank you again for participating in today's webcast.